Hello and welcome to our SEP3 project. We are Smilta, Arturus, Haocheng, Hugh, and Dalius. For this three-tier project, we have created a dating app. During this presentation, we'll be introducing the different members of the group, going over the various stages of the project development, from the initial stages to the analysis and design, then implementation, testing, and then finally a demonstration of the final result. In our group, we have three nationalities represented. We have Hao Cheng from China, myself from Ireland, and three from Lithuania. They are Arturus, Smilta, and Dalius. While our cultures were actually quite different, we actually didn't find any sort of conflicts or disadvantages to this. We each shared a general disinterest for power, which sometimes meant that people would be reluctant to take the lead. However, there was no stage where there was any kind of power struggle when somebody did start to press things forward. This was something that we were actually quite concerned with at the start of the project, but we agreed to a simple set of rules so that we all had the opportunity to develop and become better programmers without having to worry about the judgment or the isolation of falling behind.
Project initiation. We had some specific requirements for this project. Like, for example, we needed to implement some specific languages like Java and C#. For each client, we needed to make a separate GUI. The whole system needs to be in three-tier architecture, and communication-wise, we needed to implement socket protocol. We needed to consider some specific security considerations, and we need to consume and expose one or more web services. Client concept. The main idea is that you're putting basic information so people can see you and you can get a match with like-minded individuals. After meeting the person, you can rate them to give feedback so they could improve their dating skills in the future. The solution is aimed at individuals who have a lack of social confidence because it doesn't ask for personal details and it gives you feedback of how the date went. We use Scrum to break the work tasks and to complete one user story after another. In the beginning, product owner was Smilte, and afterwards, Hugh took over the role. Arturus and Hao Cheng at the beginning were the Scrum Masters, but Dalius took that role later on. So in the end, Scrum Master was Dalius, Hugh was the product owner, and Hao Cheng and Arturus and Smilte were in the development team.
So this part was made in order to represent how our system is going to work and what are the working principles gonna be. And for that, we made some diagrams to analyze and show to the client our system's functionality. So one of the diagrams is use case diagram, which shows the roles of our system and the features which are attached with them. As you can see, our program is a dating app which has two users, admin and Fisher, and we all have access to different functionality. So the following process of use case diagram is use case description. And use case description is made for every use case, depending on the user stories and to show the normal conduct of our framework bit by bit. So the last diagram which we have to make before going to design part is the domain model. The domain model is used to recognize conceptual classes, relationship between them, and its characteristics. One of its additional advantages is that it makes simpler to get an outline of a system and to show exactly how it should be implemented.
For threat model, we use software which is Microsoft Threat Modeling Tool. It was used to identify different threats in each part of the system. To identify and categorize threats, a stride model was used. Stride is often used by security experts to help and identify and mitigate the potential threats. With the help of the software threat model and objectives, preventive measures, and risk assessment were made.
In conceptualizing the matching, the one of the primary points is that users should realistically only be able to see people where their sexuality is compatible with the other users. So, for example, a straight male might be interested in a gay female. However, she would not reciprocate this interest, and therefore the matching should not be possible. This became a little bit more complex as we realized that we were going to have to record every last interaction. And we had initially engineered a solution that would involve multiple lists that would have broken down the requirements for greater searching. However, upon a bit of extra research, this turned out to be over engineering the solution. This would not be relevant until we had many hundreds of thousands of users. So we dropped that and we decided to just keep to a simple matching history based on the values you can see here. Two features that we had planned for in the requirement stage that we had not actually implemented were the questionnaire and the rating system. The questionnaire would have acted as a sorting element, most likely to make it easier for somebody to find a potential match based on their personal preferences. However, again, this required the matching algorithm itself to be working already. The rating system as well would have attached that data based on matches that have been made in order for somebody to make a rating. So these two pieces of functionality, while somewhat important in the client's point of view, were not functionally possible in the time that we ended up having. So next we'll move on to the design stage. In designing all the different elements of the project, we wanted to make sure to stick to the smart requirements, that we would create a system that would meet these requirements so that we would cut down on any potentially redundant code or miscommunication between different parts, sticking to naming conventions and specific identifiers throughout the system.
The three-tier architecture consists of presentation layer, which was implemented using Razor Pages and C#, the application layer, which is implementing using Java. It handles the business logic, processes the input from the user, establishes a new storage format, and then sends it to the data layer. As well, it processes and sends back the data from the data layer to the presentation layer. The data layer uses Web API and PostgreSQL. It exposes the HTTP endpoints and stores the data in database, which is used by other tiers. The tier 1 is responsible for collecting data from the user and presenting data, and it sends all the collected data through sockets to the second tier. The second tier is responsible for receiving requests and sending information back to tier 1 and processing data from the tier 1 and sending it to the tier 3.
Okay, so in this slide, I'm going to talk about the Tier 3 class diagram and a short overall of what role Tier 3 takes in our SEP project. As you can see, we can't actually see the methods and what's referenced here, so I'm just gonna open my Asta. And yeah, so our Tier 3 role in our SEP project is basically responsible for the authorization and authentication, database queries, and storing necessary information to the database. Tier 3 main framework is Entity Framework, which is used basically in every step when we needed to make a connection to the database or store something. So it's basically we used Entity Framework whenever we went to do something with the database. Okay, so moving on to this next slide. I'm just gonna talk about overall how all the tiers communicate with each other. As was mentioned before in the architecture diagram, Tier 3 with Tier 2 communicates through API. So basically, in this place, and tier 2 with tier 1 communicates through the sockets. Of course, it takes a long road to get to the tier 3, but I'm going to talk about it later. So I'm going to take a simple example how it works. So for instance, user wants to log into the system. So everything is done here, and he fills the inputs of like username, and then he presses the button to start catfishing. Tier 1 serializes all the data which he inputted to the JSON and sends it to the tier 3 through the sockets. And then tier 2 gets the data and sends JSON file basically just straight to the tier 3. And tier 3 also maps it to the user model, which just takes the username and password and checks in the database if the username and password is correct. If it's true, then our tier 3 is returning a response of 200, which is okay. And inside the tier 2, we have like we are returning only the response code 200 to the tier 1, so the tier 1 knows when that the user was logged in successfully. Moving on to our IR diagram. In the beginning, we said that we talked about the administrator account, which is responsible for the user activity, but we haven't had enough time to finish it, so we just made the Fisher Fisher to work, and that was basically it. And yeah, for the users part, so we used inheritance class. So basically, this is the parent class of the Fisher and admin, and as you can see, Fisher has some more information about the user. So whenever the Fisher is created, it takes this information and this information together. And yeah, when Fisher is initialized, then it takes like the data which is inside the Fisher and which is inside the user because it's inheritance. And Fisher can choose one of the sexualities which he is, and we also try to reduce the redundant data in the database, like repetitive data. So right now, you're just gonna choose one ID and you will be ready to go. Of course, in our tier 1 is gonna be shown as like if you were like homosexual and straight and so on. And yeah, there is like another table which is related to Fisher is the like reject. Like reject is basically like a history of like what person did to another one. After we made like reject table, we thought like why not to do like a table with people who have matched. So for instance, if the Fisher 1 and Fisher 2 likes each other, Fisher 1 likes Fisher 2, and if it's gonna be the opposite way, like the Fisher 2 likes Fisher 1. So for instance, if like the user ID 3 likes user ID 6, and then if it's opposite, then it'll automatically start inside the people who matched. So just basically, we thought that it's a good idea to maintain the people who have matched each other, to just get a shorter list of like getting everything. And yeah, basically that's it. We can just move on.
Next is the implementation part. Our project used the ASP.NET Razor Pages as the front-end client website. The Razor Pages is the page-focused framework used to build dynamic, data-driven websites and clearly separate concerns. Based on the Microsoft ASP.NET Core, it offers a page-based approach for building server-side rendered apps in ASP.NET Core and can consist with traditional MVC or Web API controllers. Tier 1 and Tier 2 using the socket for sending and receiving data by request object. Type is an enum show server which request will receive. Then the server will use different algorithms to process different data. Then Tier 1 will receiving the response as the byte. The system will be encoding byte to JSON file, then transfer JSON to object, which is needed.
This is the part which is always listening for new clients, and when the client connects, it passes the client socket to the thread and runs it. The outer while loop will run all the time listening for new requests unless the client calls a logout method, and it will be executing certain methods from class API communication class, which will return certain response, and the response will be sent back from this class to the client class. This is the part where actual HTTP methods are called in the API and the response is received.
I thought it would be a great idea and interesting to show how users can update their data in our system. So basically here on the left side we have a controller, a snippet of the method in the user controller. So basically, and in the first line it says authorized roles equals roles.fisher. This means that the user which has been authorized should be a fisher and nothing else. Because we want to make sure that the user which tries to update its information is logged in, because otherwise it wouldn't make sense. And we're using HTTP PUT method, and then when we're referring to the PUT method, we need to also specify the ID of the user. And our method takes the ID and takes all the information from the body and stores it inside the update model. And as I talked before, we use the mappers. So right now we took the update model and we need to update a main object class, which is Fisher. So we just did that. And then from the Fisher ID, we're storing the ID inside the Fisher class, because right now before it we couldn't do it because we don't have an ID in the update model. And after that we have, because the mapper included all the data from the Fisher class. And then afterwards we're trying to use the repository method, which is update, and we're setting the Fisher update model, we're setting Fisher class, and we're setting the password which is in the model. And if we go here, first of all, what our software does is looks through all the fishers inside our database, and if the fisher is not found, we're just throwing an error that user was not found. And if we found it, if the fisher exists in our database, then we're just having some checks. So for instance, if user haven't changed his email, then we're just gonna take all the email from the database and then just store it to the fisher class. And then the same goes for the description, person sexuality, picture reference. And yeah, just basically some simple checks. And also we were about to do the picture reference, so I thought that we will implement the pictures for each user, but unfortunately we didn't. So just there. And also if the user wants to change his activity, like if the profile is active or not, then again, if the fisher haven't changed any information, we're just taking it from the database as his old information and just storing them into the fisher class. And here also we did some kind of hashing, and yeah, so again, if the password was just a null or white space and user didn't want to change his password, so we're just gonna ignore it. If user changed the password, then we're just gonna call the method create password hash, and then we're just gonna store the hash and the salt together. And after all the if statements have been called, then we're just gonna add the update to the queue and then just save changes to our database.
Now it's the testing part. For each use cases, we have some corresponding tests. Here is the test for login. We use Blackbox for testing. We typed the right username but the wrong password to test the reaction from the system. After testing, let me show you some results. The result of the testing in relation to all the user stories which is needed to implement can be seen in this table. For the Scrum, we have finished the most of the core requirements. Our product followed the design. In the beginning of the project, we created some mock-up GUI for our website. Following the mock-up, the web page and the detailed functions have been designed and finished. Here is the demo part. Here is the demo. First, change the IP to connect to the server. Then, running the website. Here is the welcome page. Click the top right button to sign up. You can log out with your account. Let's try an account Superman. After login is the phishing page. You can find your perfect match according to your personal detail. If you don't like this feature, click skip to go to another one. After looking through the whole potential features, you can back to the phishing page and start again. If you click the like button, you can chat with this feature. We will upgrade this chatting system next version. Let's back to the phishing page. You can also reject this feature, and you will not see this feature next time. You can see the details of your potential feature. When you click in your username button at the top right, you will see your personal detail. You can edit your information and also take a look at the history to know who liked you back. Let's change the sex orientation and the description. Then click the Submit button. As you can see, some details of this user has changed. Click the Logout button at the top left to log out. As a result, we have done the most of the core functions of the dating project successfully.
As a group, we also had troubles and some mistakes which we made during our semester project. For the mistakes, we did a lot of mistakes in the implementation part because our system is not fully functional, and be thinking that the code could have a better logic behind it, and that our system is not optimized well, and so on and so on. Another mistakes which we noticed is analysis in analysis and design part, and we did make some mistakes in diagrams which we noticed after hand-in, and we made a really huge mistake by canceling one of our Scrum meetings. In problems, we had a problem with time management. It was because some things didn't go as planned, and usually we've been late for some meetings, so things took a lot of time to be finished. Also, one of the main problems was lockdown, because we had to stay inside. We had online classes, and our meetings also had to be online, and it was really hard to keep following the process, the meetings, and to be motivated for studies and to make your tasks on time. So for conclusion of our semester project, we first started with our group formulation, which we were really happy about our group, and we formulated an idea which was to make a a dating app for people who can trust other people. And after we made an idea, we started to work on a project. So we followed Scrum framework, which really helped us to keep on track every work and things we have to do. And as a group, we are really happy to use that framework. As I mentioned it before, we had difficulties in our group, which was related to implementation and also the process of our work. In a result, we think we did as much as we could, and we have put it all our time in our group project. And of course, for the future work, we will always have where to improve. And now that we know where to improve, we think that next semester we're gonna make even better semester project.